Good morning, everybody. Today we meet for the workshop of Alliance for Energy Cooperation in the industries in Europe. The main title of the workshop is Unlocking Energy Cooperation in EU Industries, Main Tools and Challenges. The workshop is organized under Sustainable Energy Week extended program, which starts from today till 22nd of October. So we use the identity of EUSEW 2021. The speakers of Alliance are as follow: myself, Emil Lezak from ISNAP representing Incubis, Dr. Andrea Coleman, project coordinator of Energy Institute at the Johannes Kepler University Linz, represented Sparks, Mr. Nick Purhouse, senior project manager of Integrated Environmental Solution representing SOWAT project, Mrs. Zenaida Murao, heat of energy unit from Energy representing the Embers, and Mr. Max Brower, project manager of Institute for Sustainable Process Technology represented ACES. Before starting the presentation of each of the project, I would like to present our Alliance for Energy Cooperation in European Industry. I will start to be briefly. So the Alliance is collaborative initiative arranged by five projects: Embers, Incubis, RSS, and Sparks. Together we are 64 unique partners between 18 European countries, which we received 14.5 million euro in funding, total for 5 projects. Well, this start with the call between the coordinators, dissemination leaders on that project, looking for the synergies for identify potential areas to join work on the decarbonization of energy industries. So some screenshots from one of the previous first meeting between the coordinators, dissemination leaders. Then we held in November 2020 webinar in order to set up, identify and set up synergies between us. It was brainstorming discussion to set up what we want to achieve, what are our objectives. After that, we prepare letter of intent for the creation of our Alliance for Energy Cooperation. So after that, the logo has been created by some of us, by some of the dissemination leader, and first of the poster, first of the banner have been delivered, and we are using this for the dissemination communication activities. What this alliance is? It is potential for energy cooperation and waste heat recovery, as has been mentioned, for the decarbonization of the industry. Alliance is set up because energy represents up to 20% of the total production cost in energy intensive industry, and it also reflects for the significant amount of energy which is lost up to now in this sector, and mostly in this in energy intensive companies. So the carbonization of the energy supply and reduce of the energy waste, reduce of the CO2 emission was our main objectives. And more particularly, we want to enhance collaboration for both energy efficiency in new industries, maximize impact to improve quality of relevance of the outputs generated by each of the project conforming by the alliance, both industrial symbiosis and waste heat and waste cold recovery and reuse, and of course contribute to the 2050 goal of zero net carbon emission. So the logotypes of our 5 projects embossed in Incubis already said, so what, and as parts. As has been given on this list of the speakers, the first is the Incubis. So the project start in May 2020, will finish in April 2024. We are approaching several barriers as high risk of the energy symbiosis project, low risk tolerance for the investment, and lack of the skills and capacity to properly assess. The problem is that energy symbiosis initiative of the project always face at the beginning, on the development stage, when objectives are not clear, the solution are not clearly defined. So we in Incubis want to set up a facilitator. We call this energy symbiosis incubator, which tackle techno-economic evaluation, identification of the potential opportunities, industry management and representative training, as well as project evaluation. Project means that the project for each of the identify energy symbiosis activities project, and financial and investing advice for particular project for energy symbiosis. So here is the timeline of Incubis project, divide in several stages. So at the beginning, we start with the stakeholder engagement in 5 European regions, which I'm going to show in which region we start. Then we already prepared the preliminary assessment, and now we are trying to find synergies in that region, determine feasibilities, and the next stage will be to implement activities such as financial and technical assessment in order to set up those synergies in each of the project, deliver on our energy symbiosis incubator, all necessary documentation in order to follow each of the energy symbiosis project. What was our motivation for the target audience for implementing symbiosis? So the first one, expanding services portfolio and increases profit for the companies such as ESCO, minimize vacant land rate, improving extending services down the synergy life cycle. This is for industry symbiosis facilitators, decreasing cost and increasing revenue for anchors tenants, and environmental social benefits for the municipalities, as well as CSR benefits for the ESCO and anchor tenants. Here we have delivered this graphic showing interconnection between the activities. So regarding the regions, we have the 5 regions in the Norway, UK, France, Germany, and Spain, covered by our partners such as AD Cluster, University of Hull, Sofis, Covestro, and Symbiosis. My role as here is in the Incubis project is the dissemination communication activities in order to communicate all the achievements and the results performed during the Incubis. And 5 regions. As I have mentioned, the first one in the Norway, it is industrial mix, mostly non-ferrous metals and other process industries. In UK as well, industrial mix, cross-sectorial, all mostly in the energy-intensive industries. In Spain is a similar type of the cluster involved in the project, focused also on the energy-intensive industries. In France, mostly dealing with the iron, steel, and the metallurgy, and in Germany, as the partner who deliver this cluster, it is about chemicals. So if you have any question related to Incubis activities, etc., now is good time to ask me. So I will be glad to give you the feedback on it. Jakob, do we have any question about our project, about Incubis?
Yes, I have one question for you.
Okay.
It was published only now. Good morning. I have a question to Mr. Lezak. What were the main points you considered to select the demonstrators, and what are the requirements for industries to be included in Incubis?
Okay, maybe starting with the second question. The main requirements was to focus on the energy-intensive industry, such as chemicals, papers, metallurgy, non-ferrous, among others, identified by the Commission, and that's why in Incubis, during the preparation stage of the proposal, the clusters or the partners who could provide the cluster has been identified. And of course, geographic location was also important, because there are plenty of differences on the administrative economic issue, which are challenging in each of the countries. So that's why we have choose those five region with the different sectors, and also because of the different procedure relating with the financial aspect, and also administrative aspect related with industrial symbiosis project within those clusters. So I hope this could give right feedback for the person who asked on the Incubis activities.
Yes, I think so. So at this moment, I see. Thank you, Emil. We don't have more questions regarding Incubis, so I think we can proceed with the further part.
Okay, the next speaker will be Dr. Andrea Coleman, representing Sparks project. So, Andrea, the floor is yours.
Thank you very much, Emil, for presenting the Alliance and Incubis. Hello, everybody, and warm greetings from Linz in Austria. I was the coordinator of the Sparks project. In contrast to the other projects, Sparks has already finished this year in June. We were a team of 13 partners from 6 countries: Portugal, Spain, France, Austria, Italy, and Turkey. And we started to work on the question of energy cooperation in March 2018. Key partners in our project were 5 lighthouse industrial parks. Next up, please. these five lighthouse parks were, as I said, our key partners, and we worked in very close collaboration with them. 2 of them were in Austria, 1 in Italy, and 2 in Spain. What you can see on this slide in the upper left corner is Enshafen. This is an important port along the river Danube, has a very large container terminal, but is also a pretty large mixed business parks with companies ranging from SMEs to middle-sized industrial companies. The second very interesting park that we had in the consortium was Ponte Aigola, which is very close to the Italian city of Pisa in Tuscany. And this park is one of the leading regions of Italian leather industry, with about 80 SMEs in the park, all of which work in the leather industry. Another completely different park that was part of our project is Chemie Park Linz, which is located here in Austria. And our partner there is Borealis, an international chemical industry company, which is also one of the largest energy-intensive companies in Austria. So it was very interesting to see what a highly energy-intensive company can do in a park setting. And finally, we have 2 very nice parks, as you can see here in the lower right corner in Basque Country in Spain. These are smaller parks in the rural countrysides with about 30 SMEs from very different business backgrounds in each of them. So what we did and what we set out to do in S-Parks was to work with these 5 parks on finding out how we can support them to develop energy corporations for them and with them. Next slide, please. What I want to do in the next few minutes is just to give you an impression of how we approach the topic of energy cooperation in industrial parks in our project. Our key objectives were to develop replicable instruments for energy cooperation and to provide industrial park managers and the companies in the parks. We worked both with the administrative level of the parks as well as with the individual companies. And we wanted to give them all tools that they can use to make energy cooperation in their park happen. Our work was not only desk research. We were in all those parks. We discussed with companies, with park managers. We made many interviews to find out what is actually needed. And from what we've learned there, we developed our tools. We developed business models. We designed contracts that can actually be put to use. And another very core thing that we did, we took a deep dive into the legal and regulatory frameworks that we found in these countries and used them to write specific policy briefs that explain the situation in these countries. There are similarities, there are differences in the way that different European directives have been implemented in these parks. So it was a very interesting exercise to take a deeper dive into Spain, Austria, and Italy when it comes to energy cooperation. A final thing, and I'm going to talk about that at the very end of my presentation, is an online tool and a platform that we developed. Next slide, please. You can find under this link that you see here in the presentation a link to the S-Parks community. What we try to do there is, as I'm sure many of you work in Horizon 2020 projects or now in Horizon Europe projects, so many deliverables, so many reports come out of it, so many interviews are done and so much activity happens. And it is difficult at the end of a project to just go and sit down and read hundreds and hundreds of pages of deliverables just to find that bit of information that you're actually interested in. And we hope that with the e-platform that we designed, we can give everybody who's interested in energy cooperation a nice, easy to use platform where all the core information that we've developed, all the really interesting things that we found out in our project can be easily looked at. And wherever you want to take a deeper dive into a specific topic, you will also find, of course, all our deliverables on this platform. What this platform also does and links you directly to is the initial assessment tool. When we set out in S-Parks, we knew that there are many high-level programs, software tools out there with which you can do an in-depth audit, which of course, is whenever you go and set out to do an energy cooperation project, the final step in planning and getting the experts on board. What we wanted to achieve is to have like a beginner's level energy cooperation tool where you can very easily just find out what could be interesting for my park, what kind of energy cooperation solutions could I implement given the very specific situation of my park. It is completely free. It is easy to register. You can play around, nothing can go wrong. I highly encourage you to use it. It is up and live and is going to run hopefully for many more years. We're currently looking at a follow-up project to SPARKS to dive deeper into energy cooperation, extend our ideas to other industrial symbiosis, cooperative measures, and yeah, hopefully have developed a good starting point for the Alliance and for energy cooperation with our project.
Now is the time for question to you, Andrea. Jakub, do we have some question for SPARKS projects? Maybe could you tell us?
Yes, I have to Andrea one question from Christopher. Andrea, you said SPARKS plans to contribute to the directives and standards. What are the fields in legislation that you hope SPARKS can improve?
Thank you for the question, Christopher. So in the parks that we looked at, what we tried to find out is how the different levels of jurisdiction and legal and political levels come together. A very simple example, in the Enshafen Park that we have, this is on the border between two federal states in Austria. So on the left side of the Danube, we have a different political team than you have on the other side. The streets that run through that park either belong to the community, the village community and municipality there, or to the Upper Austrian federal state. So we have, whenever we want to do something in Enshafen, we have to keep in mind that this is a complex situation that involves political stakeholders on different levels. We saw similar things in the other parks, and that was one of the things that we've worked out and also put into the policy briefs that we wrote. So what can be done in a park and what kind of barriers do you find just from the political and legal setup of that park. The other thing that was a very big topic in our project is data security, data privacy, and what kind of setups we can find so that companies within a park can find themselves in a situation that they can trust and are trusty enough to exchange energy information, which obviously is a very sensitive topic for many companies. And as I said before, we have different parks. We have mixed business parks where it doesn't really matter for the one company whether or not the other one knows how much electricity they use because they work in completely different sectors. In contrast, in Italy, in the leather industry park, we have companies that are in direct competition to each other. They have common problems or common challenges that they are faced with, but they're also competitors. So I would say these are the two core things that we looked at. What do we need to know about data transfers? How much data needs to be transferred? Do we need an intermediate party? Do we need someone who's completely external to a park to make these energy cooperation projects happen? And if yes, what does that mean in terms of the General Data Protection Directive and the way it is implemented in different countries?
Okay, thank you, Andrea. It was completely feedback given to Christoph. If I could remember, you are perfectly on time. Even I could say that you have some minutes more, but let's go to the next one. So now Nick representing the So What project. Nick, the floor is yours.
Thank you, Emil, and thank you everybody for attending today. So my name is Nick Pershaus. I'm the project coordinator for the So What project. Although on this slide it looks like the project is due to finish May in 2022, we're actually going to extend that for another 6 months, so it will be finishing towards the end of 2022, and we've been sort of running since June 2019. So What aims to try and use some of the software that IES already has available, and also enhance that software to allow the auditing, planning and simulation of waste, heat and cold from a manufacturing or industrial site, and try to understand how that can be used either back in the industry itself or in the wider community, and also how it can be integrated in with other renewable energy sources to match, I guess, local demand and supply.
Next slide.
Next slide. Thank you. So this is really just an overview of what the So What overall platform will be able to deliver. And to start with, on the left-hand side is all really about allowing our the user of the tool to baseline the waste, heat and cooling that might actually be available from their specific industrial facility or within their community. The middle column is then around being able to simulate different technologies and scenarios that you might want to set up, and optimize different aspects of different technologies to do with waste heat recovery and waste cooling, allow you to model how you can integrate that waste with also other renewable energy sources, and simulate how you can balance that with forecasted demand and supply. And on the right hand side, there are reporting and decision type tools that allow the user, it doesn't necessarily have to be an expert user or an engineer. This is also aimed at financial aspects of different organizations. So we're looking at various different financial, energy and environmental KPIs, and allowing the user to actually visualize what might be done. We're also trying to set up automated software at the industrial facility to allow us to continually collect data from different processes or different waste heat recovery technologies that can then be fed back into the software to allow, I guess, monitoring and validation, or also ongoing sort of maintenance and operation to make sure that things are actually occurring as they should do. Okay, next slide, please. So this is an example of a Sankey diagram that's been produced through the software, trying to look at all of the different sources of waste heat and cooling and the different sinks, and then trying to understand out of all those different processes where is the waste heat found. So this is actually a Sankey diagram from the Pessione distillery. It's Martini and Rossi distillery in Italy. And this is just some of their product lines, and just showing where different heat and energy sources where they go to. And at the sort of towards the top right hand side, you'll see there's a reddish bar, and that is where we've identified that there's an element of waste heat to try and recover. And in the table that you see underneath that red bar, that's also split into different temperatures and grades of waste heat. So next slide, please. The idea, once the user has that picture, is that we can now simulate all of these different waste heat recovery technologies, to try and understand what you can actually do with that waste heat. Can you actually, is it technology that's to do with waste heat to heat and actually using that either back in different processes or actually to the wider community, or is it for thermal energy storage or trying to do waste heat to cold or heat to power, for example? A lot of these technologies are already mature technologies and available in the market, and some of them are actually near to market technologies, but we've now done the development in the software to allow all of these technologies to be simulated. Next slide, please. Oh, okay, is that all? That's the slides that we have. I think that was just on the technologies. This is just an example of some of the different demo sites. So this is Imerys graphite and carbon site. So it's just an example of all the different types of demo sites that we have. We have about 11 different demo sites. And we've tried to look quite broad across the different sectors, and some are just interested in using waste heat back into their own facility, and some are more interested in trying to understand how they can feed local district heating networks, for example. So if you just go to the next slide, please. Yeah, keep going through. This is just an example of what these guys do. And yeah, that's all the questions, all the slides that are there today. There is some other information available on the website for So What. It's just sowhatproject.eu, and I welcome any questions.
Jakub, please let us know if Nick could give some feedback for the question on the So What. Do we have some?
Yes, I have two questions now, I see. One is from Katrina. Nick, good morning. What approach you develop for economic assessment?
Okay, so there is a specific module that we're actually due to develop in the software. We've not actually finished that yet, and we have a Swedish partner, IVL, in the project that was looking at the economic side of the different technologies, and also we've also started looking at they've done a lot of research on cost benefit analysis of different technologies, and also risk of inputting different technologies into different industries, and we've recently completed that work and now have to implement that in the code when you run each technology in the software to enable sort of different economic outcomes. I hope that answers the question.
Yeah, I think so. This is quite enough. Do we have? Yes, Jakub,
yes,
you mentioned that we
I have another
questions.
question. There is no name, but we're from August. Could you explain Sankey diagram setup? In example, are there real data from industry, or you have it estimated?
No, so that's a good question. I think this is probably the biggest challenge that we've actually faced is getting real data. It is real data, and the way that we've been able to do it is obviously there's a lot of issues around data security from different industries. So why I've only been able to show one Sankey diagram there is out of the probably 5 or 6 industries that we were just looking to simulate for this baseline. I think we only got actual two sets of real live data, because other industries just didn't want to pass on such detailed data. So what we have is really where they've got any metered data for their different, I guess, product lines and processes, mainly to do with energy, then that's where they pass that through to us. Yeah, it's real live data, and what that allows us to do is then create we'd call it a calibrated baseline in the software of how that production facility is actually using its thermal energy, and what the waste heat coming out of it is. But yeah, it's been very difficult to get hold of that data and actually organize that within the software to make it as real as possible.
So I would like just to add, Nick, that I'm impressive on the Sankey diagram when where the calculation is from the real data. From my experience, I know that it's very challenging to have the inputs from the industry as the information is confidential, sensitive, and have it like that. Very good work. Just to say. So
thank you
for your presentation. Okay, now is the turn of Zenaida from Ineji, representing the Embers project. So Zenaida, the floor is yours, please.
Thank you, Emil. Good morning, and thank you for being here. So I'll present very briefly the Embers project, which is a sister project to EUSEW that has been just presented by Nick. So it means basically they got funded within the same call. So you'll see that as I present some of the solutions we're developing might be at least trying to tackle the same issues. And there will definitely be some overlap, let's say, between what we are developing and what EUSEW is developing. So on to Embers. So as I said, it's been funded under the same call as EUSEW. We started the project in September 2019, and it's due to end in August 2022. But as EUSEW, we will also ask for an extension, and so it should end actually sometime beginning of 2023 if all goes well. So we have 16 project partners from 7 EU countries with different expertise. Yeah, we've seen also covers 36 months. So you can see some information on the project on the left-hand side of the slide. So you can follow up both on basically on our social media and also our project website, which has a lot of information that I'm not going to, well, I'm going to share only a very small portion of the information with you today, so you can find more about the project on any of the links on the left. So just as a very high level objectives that we had for the project. So in terms of some of the outputs and some of the objectives, so we within this project we will develop an open source energy modeling platform that will help industries identify some technological options for reusing their excess thermal energy. This basically means that within the tool, you'll be able to explore different scenarios for how you may use the available excess thermal energy. And another, I guess, requirement and in the same time specification of our tool is that it can be independently used by a wide variety of industries and actually a wide variety of stakeholders. So when I present some of the use cases, we'll see a bit of that. And also in different EU geographies. So this means basically would have to have some information that's used as input in some of the modules, let's say, within the tool, have to be tailored to specific locations within Europe. Emil, please, if you could, okay, share the other slide, thank you. So you can see on the left a bit of so if you go to our website, you can see the video, and this is as part of the video trying to explain exactly in let's say in a simplified way what we are trying to do. So basically what we, within this tool that we are creating, so in principle, we would have the sources of, let's say, of excess thermal energy, being able to provide some data about where they're located and potentially some background data that we then use to calculate the excess thermal energy that's available to be recovered and then reused. And basically what the tool will provide is an output in terms of different technological options, so different with all of the different costs and also benefits that that an industry or another stakeholder that has access to thermal energy. Of course, it doesn't have to be just industries. We know that some other types of stakeholders, such as, for example, data centers or other types of commercial buildings, might also have access to thermal energy available. And basically what the tool then provides is an overview of all the different ways in which that excess thermal energy can be provided. So it identifies users with geographic relevancy. That means basically it is able to locate whether or not once, let's say, a given source is identified, whether or not there are potential users for that excess thermal energy in the vicinity. The tool will also be able to match quality and temporal profiles of excess thermal energy, so basically on the supply and on the demand. It will explore, as I said, the cost-efficient internal and external routes. So this has to do with something that Nick also mentioned that the tool is able to do. So basically, it's not looking, it's looking at also options, let's say, within the industry itself, but also options of how that industry could share that excess thermal energy with other neighboring industries or other neighboring, let's say, users in other sectors, such as, for example, buildings. And we also have a component of the tool that is able to assess what sort of business model might be more effective for that particular technological solution that is, let's say, the least cost solution, and also analyze potentially some policy instruments that might be able to incentivize, let's say, the implementation of the solution. Emil, sorry, could you, thank you. So as I said, this open source tool has different components, and actually these different components are also a result of the different modules. So it's a modular tool. That basically means the way it's being built up is that even though we have a specific module that does some part of, let's say, of the analysis, in the future, particularly developers could in principle substitute one module by another that does something similar, that has the same types of output. So currently we have 4 different modules within the tool. We already have the individual modules have already all been programmed, and we are currently within the, let's say, our work progress, we're integrating them all in our final platform. So we have one module, which is the GIS module, that basically looks for the best, lowest cost pathway to connect different sources and sinks they're related with this route to explore or to valorize the excess thermal energy that's available. And then we have one techno-economic module, and the techno-economic module, basically what it does is it does a least cost optimization or provides a least cost optimized technological option that takes into account all of the different things we can do with the excess thermal energy. So once we've identified what that excess thermal energy is in terms of quantity and quality, and once we've identified geographically compatible, let's say, users for that heat or cooling, depending on what we have available, then basically what this module does, it runs all the different options, some of them very similar to the ones that Nick showed, and basically it then the main output is then saying, okay, so if you want the one that has the lowest cost, this would be, so it shows what is the option in terms of basically demand and supply and all the chain of technologies you need to deploy in order to connect demand to supply. The market module then basically provides an analysis on top of, let's say, this technological, this physical solution, an analysis in terms of the types of markets that could potentially explore in terms of valorizing and selling this basically this heat from the let's say the source to the different users, and it explores different types of markets. So the centralized markets as well as let's say the peer-to-peer markets. So that's something that we are exploring, and specifically within one use case. And then let's say as something that wraps all of this up, as we said, the tool will also allow the users to explore different business models in order to see what would be the best, let's say, outcome in terms of their structure, especially because, of course, also ownership of different parts of the network are also very important once we are connecting all of these different technology on the user side, technology on the provider side, and also the technologies to basically transport and distribute this excess thermal energy from the supplier to the user. Emil, if you could just have the last slide. Thank you. And so just as a last slide, just to give you an overview, a very quick overview of what sort of case studies we have in the Embers project. So the idea is then to test basically the tool that we are developing, but also in a sense improve it with some of the outcomes of the case studies. And so the idea was that we would have a set that was comprehensive enough so that we could test all of the different capabilities of the Embers platform. So we have three types of basically of case studies in our project. One of them is the industry-focused case studies, where basically the provider of the excess thermal energy is an industry, and then we are looking at both within industry users as well as users where potentially that excess thermal energy can be shared with other industries in the vicinity. So we have one industrial park in Greece where we're testing that sharing between industries, or with other, let's say, sectors, both buildings or a combination of industries and buildings, which we are testing both in Portugal as well as in the UK. And in terms of the network-focused case studies, so these case studies are the main goal was to have, let's say, the point of view of the networks, because of course we can either have existing networks, and one of the use cases is of course to basically capture this excess thermal energy and basically link it or provide it to an existing thermal network. And so basically what we are doing in these case studies is precisely testing this option. And we have one case in Portugal, another one, and one in the Portugal is both with heating and cooling. One case in Lund, where we are looking at the expansion of the capacity of the existing network by basically capturing or linking to available local excess thermal energy from local industries. And the last one, a potential link between the district heating network for university campus with the neighboring industries. Just as a final, maybe just a few more seconds just to finish the super user and market focused case study. So we have one case study where we are trying to see what happens when we have a particular user of the tool that has a lot of data available, both on the building side as well as on the industry side. And so this is with the Portuguese Energy Agency, where they have precisely, so they're managing the national system for certification of industry, for certification of buildings. And the idea there is to see how we can use the Ember tools to look for synergies between, let's say, the excess thermal energy available in industry and the needs of the buildings. And finally, as I said, so since we have this market module that can explore peer-to-peer types of relationships between different actors in the market, the idea here is to see whether having a peer-to-peer solution would actually increase, let's say, or valorize the available excess thermal energy and incentivize the local decentralized heating market. So this is just an example of the Greek case study. The Greek case study, so it's for the zone of Volos, where we have an industrial park with about 50 active industries. And here we've already done, so our partner in Greece, Crash, has already done an initial characterization of the, let's say, of the available excess thermal energy from different industries, but also from the needs of those industries. So basically these industries can be either sources or sinks, and actually in some cases they might be both, depending of course on the range of heat we're talking about. And also they also have made an initial characterization of the buildings in the neighboring city of Agio Georgios. So basically looking at how some of this thermal energy, external energy, could be actually connected into or used by the neighboring buildings. So we're looking at a mix of solutions here. So both looking within the industry, between industries, and between, let's say, industries and the neighboring city. And so this is the case study we're currently modeling. Yeah, so the just initial assessment that they made. So we have about from 10 industries where we already have the data, and we had some basically responses. Six of them can be sinks. Basically, they need thermal energy in certain ranges of temperature, and 4 of them are sources. And actually, there is quite a big potential there for basically recovering this excess thermal energy. And basically what we are now simulating with the tool is the economic feasibility of the project, looking at, as I said, at all of these different options and the heat storage requirements, because of course we have not a perfect match between the profiles of supply and the profiles of demand. And that's it.
Now we have that. Thank you, Zenaida. Now we have the time for question, but before that, I could say that is a really challenging project to coordinate industries across the Europe. So I'm impressive as well. Well, Jakub, please let us know now if we have a question for Zenaida on the embers. Please read it.
Okay, Zenaida, so thank you for the presentation. At this moment, we have we received 2 questions for Zenaida, and also there is one for Nick, but we start with Zenaida. So the first one is from Mikkel. He asks you, how big is the competition in the market of heat and cold for industrial partners?
How big is the competition? I don't understand. I mean, is it? The question can be referring to several things. Is it the competition in terms of implementing the solutions, competition in terms of these tools that we are developing, or let's say, because the heating and cooling. Yeah, go ahead.
I think, Zenaida, that both. It is a generic question, but I think if you could provide the feedback on both aspects, will be enough. At least for me. I don't know.
Yeah. I'll do that. So maybe in terms of the project itself, which is so the main output is a tool that could do this analysis. So in terms of whether there is another tool like this out there, there are tools that do part of this analysis. The main point here was to develop an open source tool. That means everyone could have access to it. Also, that was an easy to use tool, and that was collaborative. So this means basically different stakeholders that are interested in implementing a solution could actually work together on developing their own solution to see whether or not their sinks and sources are compatible. And another thing that we definitely was something that we identified before the project started was that typically these types of solutions are in-house solutions. So basically, this is usually consultancy firms would be doing this type of analysis, and so there wasn't really a tool that allowed the users to look at the whole chain of connecting sinks and sources, and also where they would be able to be flexible enough to create different scenarios. So as many scenarios as they wanted. So basically, that was the market niche that this tool was trying to fill in terms of a gap. In terms of the markets for heating and cooling for industries, I would say there is a lot of potential, and even for within, let's say, the industry itself. So within industry, as well as sharing between industries, there are a lot of barriers to implementing some of these solutions. There are definitely technological solutions already available, both and there are several industries that are already doing this. So we have several practical implementations in terms of industrial symbiosis, where heat from one industry is being used, heating or cooling, or heating that then turns into cooling, that's being used by other industries. So we have, of course, the quintessential example, which is the one in Denmark for the I keep forgetting the name. There is one very famous one in Denmark that has a big industrial cluster that has oil refineries and has a catalyst, a very big catalyst, a company. I can add that in the chat afterwards. For some reason, I just blanked on the name. And there are, of course, several examples of big heating and cooling networks that are already connected to access heat from industries. So in terms of there being out there some practical solutions, there already exist. But I would say this is a market that has still a lot to grow. and especially as we are looking into the lower thermal, so low temperature, let's say 4th generation district and heating and cooling networks, because in those cases we can connect additional sources, even if they have lower, let's say, temperature, we can connect them to the network. And so this is already being something that's being looked at in terms of also urban areas where you have, beyond industries, you also have other potential donors, such as, for example, data centers. I don't know if that answers the question, but
I think it's completely, Zenaida. Feel free to use Q&A session chat to provide some links for your project, explaining that. Just relating this question, you mentioned the consulting company. I suppose that was plenty of work collecting the data and analyzing this from the respective industry which represent in members. Thank you. The second question, Jakub, could you let us know?
Yes, the second question there is from Maria. She asks, are there business scenarios going to be implemented beyond the project?
Yes, so the idea is that, well, the tool itself would be able to guide users into exploring different types. So it has 3 different models of business models, basically 3 different structures of business models that the users can of course explore. And in the case of the tool itself, of course, then the users of the tool could in practice implement any of these 3 structures of business models once they implement the project. So just maybe one clarification: the project is so this is basically the tool is supposed to be used, or is intended to be used at the planning phase, when basically the let's say the different users are trying to assess whether or not this would be a route to, for example, improving their efficiency, reducing, let's say, some of their emissions by, let's say, decreasing their own energy needs, or in a view of, let's say, sharing that resource that they have, whether that in a systemic way could then contribute to both reducing emissions and basically increasing system efficiency. In terms of the business models for the use cases that we already have in the project, we do have one of the tasks is precisely supposed to. So when we look at what we are going to do in the different use cases, our final output is precisely a business model, let's say, and also so let's say a report of the financial, an assessment of the financial feasibility of the implementation of a particular situation. So we are going to develop individual business models for each one of the use cases.
Okay, thank you, Zenaida. It's quite.
We also have a comment from Mikael to the previous question. So he meant it was related to the market situation, but he thanks for the answer. So I think the answer was satisfying.
Yes, also, indeed. Jakub, could you tell us the question for Nick, before Max's presentation?
Yes. So Nick, the question for you is, when do you expect the SOWOT tool to be ready?
Okay. So we are expecting it to be, I guess, fully ready. That will be in its entirety for March next year. What we're hoping to do is to be able to release aspects of it for the different sites to test towards the end of this year. So really in a couple of months, we're going to be actually testing parts or different modules of the software with the demo sites, and there'll then be a period of obviously just trying to fix different bugs and issues, and then really by March next year we'll have the final tool that all the sites can use in earnest. And the idea is that they then use the tool to actually come out with, I guess, real business cases to take to their board or whoever it might be to actually try and implement some of the technologies.
Nick, if I could maybe extend the question, indeed the setup and deliver the tool is plenty of work to correct the IT back. Are you going to have some trials with already defined stakeholders, or you are going to approach them by the same partner, industry partners? What is the procedure in that case to to have a look if the tool works or not?
I'm sorry, I'm not sure about the question. Could you repeat?
I'm guess that you are going to make some trials with the stakeholders already defined in the project. So what will be the procedure? Approach them by each of the partner, or I don't know, or you will connect with your industrial partners, and industrial partners connect with the other close collaborative, clients, whatever.
Yeah, it can be either. In the project, we have some sites, particularly in Romania and in Sweden, that are interested in the community aspect, and they are very much interested in trying to understand, I guess, from either a local authority or an ESCO point of view, what are the areas in the local sort of district that can supply heat, and where can the demand to supply that heat to come from. So there's an aspect of the software that you can enter in from that perspective. But then if you're just a single industry, then yeah, it will just be the industry by industry sort of looking at it, and we have a methodology for the industry to say, first of all, they want to try and recover and reuse the waste heat in their own facility, really, before obviously looking at where in their surrounding community can they transfer that heat to, and where can they connect into.
Okay, thank you, Nick, for answering my question. So now is the turn of Max, who will give the presentation on EUSEW project. So Max, the floor is yours.
Thank you, Emil. So hello, everyone. My name is Max Brouwer. I work at ISPT and for the EUSEW project. So as you can see, it is a consortium of the partners you see on the screen. We run from June 2019 to May 2022. But the goal also of the project is to also create a movement and have impact beyond the project. Our goal is to we have like a concept that we call an eco-region. And so wait, let me see. This slide is not exactly the same as I prepared, actually, but so our main goal is to reduce CO2 emissions in industrial sites and business parks by developing eco-regions or supporting existing eco-regions. For that, I think there's a next slide which has a definition. So with eco-regions, what we mean with that is like it's sort of an umbrella term. So there's a lot of terms. There are a lot of clusters from businesses that you can call like an industrial site. You can call it a business park, an eco-industrial park, lighthouse areas. So there's a lot of different terms going on. So we decided with our EUSEW to introduce a new term which we call eco-region. Which is usually an industrial site or a business park, or it can be different assets, so such as data centers or office areas or campus sites that want to reduce the energy consumption, increase the share of renewables, and create energy efficient energy systems with their surroundings. So it can be inside the cluster or also beyond the cluster. And this is a concept that we call an eco-region. And in our EUSEW, we start out with 3 eco-regions that you see on the screen. So we have Nijbock from Denmark, we have Antwerp in Belgium, and we have Lombardy in Italy. And this is the starting point of the project. We want to expand that to more eco-regions. So important is that every eco-region has an anchor organization that is responsible for managing an area. This can be such as something like a park management, but sometimes it's a government, like a governing organization. Sometimes it's We also saw an external consultant that develops new ideas for an area. So that is the starting point usually of an ecoregion. So you can go to the next slide. Okay. Yeah, so this is a little bit what it looks like. And we, during the tool, we develop tools and a knowledge hub. So what I said is we want to create ecoregions, and we want to have this also as sort of a movement for past or beyond the project. So that's why we're looking currently in a lot of detail in these ecoregions and how this development works. We also looked at previous projects in Horizon 2020, and we looked at academic literature to see what kind of barriers people come across, what kind of solutions they've discovered, and to improve these type of energy cooperations. And during the projects, we found out that like a lot of the issues that are mentioned are related to things like trust, and are also related to like the complexity of long-term relationships between public, private, and residential organizations. So this is a very complex system, and we thought like a lot of tools that people use to solve this were actually focused on more the social and more the collaborative aspect, like how to set up relationships between organizations. So we designed a couple of tools during the project. The first one is already published, which is the RACES self-assessment tool. This is a tool where you can fill in all the different project ideas that you have and then self-assess the maturity of your consortium and of your project, and analyze whether it's what are the next steps for your energy project. The second one is a legal decision support tool, which is almost finished right now, so it's coming up soon, which will help creating contracts and generating a contract actually between a supplier and a customer. And it also has a European guide for the European legislation. And finally, there's an energy management platform, which visualizes all the different energy flows inside an ecoregion and helps find the connections of energy flows. So these three tools. And in addition, we want to disseminate also everything that we learned during the project and also with the network that we're setting up, also together with you in Alliance for ECI. And we collect everything inside a knowledge hub. So we're collecting a use case library, also together with your heat and power. We are collecting training materials and training courses and putting them in an environment with a search engine behind it. And finally, we've developed a serious board game that helps people put on the different shoes of different organizations in a energy cooperation project. Yeah, I think you can go to the next slide. Okay, so the slides are a little bit. So this is a bit more in detail what the three tools are about, and you can find more information on it on the website. And we're also preparing videos for them. The self-assessment tool is already published, so you can find a lot of information about that there. Okay, you can go to the next slide. Oh yeah, so this is a short introduction about one of the ecoregions in Lombardy. But there's a couple of projects actually going on in the Lombardy area, which is a lot about, as you can see here, about heat recovery and connecting them to a district heating network. And we're looking into using the RACES tools in the environment. But if you want more details about this, I can always connect if you have questions about it to my colleagues. So, yeah.
I think it is last slide on the RACES project. So now is the time for question answer session. My question is as follow. You said put right shoes to the right person in this funny way. Let's say I imagine that at the beginning of the project was quite enough. I could say even plenty of particular interviews with the managers, with the relevant expert on the aspect which you approach in the project. I'm right.
Yes, we interviewed different parties in this supply chain. Yes.
Could you explain a little bit in detail, just little, how you perform this? You have asked about memorandum of understanding, detailizing some confidential information, whatever. If you could just put in the bullet points, how was the process of the performing those interviews? If you was involved, of course, in this stage.
Yeah, what we did, we split it up a little bit in different countries. So I interviewed with a colleague a few people in the Netherlands, and it's a little bit different from who everybody spoke to. So I spoke mostly with some provincial government, so policymakers who are trying to develop approaches for business parks in their area, so within the province, and these were mostly they were open conversations with a couple of questions. So we asked them questions like what kind of issues do you encounter, how did you solve them, and things like that. What I found with the policymakers is that they're currently, in the Netherlands at least, they're trying various approaches, such as trying to promote energy cooperation by putting actually a physical location on the business park, which is supported by a government and advisors to help with energy savings on that business park. So that was one approach that I saw. We also saw something which you can call like an innovation or social lab that was also present on the business park, that actually worked more closely together already with the businesses that were in the park, and they were developing a roadmap on how to reduce energy and also how to prepare, in this case, a hydrogen network on the area. So they're actually starting concrete projects. And the third that we saw in the Netherlands were like advisors that were sent by the government to the business parks to do energy scans and have that as a starting point for a dialogue. So those are some examples that came out of the
Okay, thank you for feedback. I see that it quite wide, let's say, approach. I mean, approaching the several types of the stakeholders. Thank you, Max. I hope that we have more questions from the audience. Jakub, could you let us know if you have something for Max?
Yes, Emil. We have one question to Max. Somebody is interested if you could go more into details related to the requirements for ecoregions.
Yes. So there's actually on our website, so r-aces.eu. There's a commitment page where somebody can apply to become part of the r-aces network. And the requirements, we try to do it at the moment very low effort. So we have mostly a goal. So the goal is to want to reduce emissions and set up energy corporations in an area. So that's the most basic, I think, prerequisite to become an ecoregion. And as I said, there's a lot. We see a lot of different types, but what we usually do is look at a business park or an industrial site should be there, and then it has to be a project on either energy corporation, so develop new energy systems, or have a collaborative effort to reduce energy in the region or produce more renewables. So we do quite a lot of different projects from also district heating to hydrogen. Yeah, so it's quite broad scope.
Thank you, Max. Jakub, do we have maybe more question?
Yes, we have one question to Zenaida. So Zenaida, can you look?
Yes,
Okay.
yes. So it was about the policy instruments, right?
Yes.
So in terms of the policy instruments that we are considering within EMBERS, so we have so currently we are introducing the regulatory framework for basically for heat networks and for using heat from industrial or other types of sources, so the excess heat for networks, so those will be part already of the platform itself. So that means basically if anyone is exploring a project within a region that we at least are studying currently. So that basically means we have examples in Portugal, in Denmark, in Sweden, in the UK. So those case studies, because we are working on them, we will have the relevant, let's say, parameters from the regulatory framework, which might influence the overall profitability of a certain profitability, and on the other hand, also the requirements for a certain project to be implemented. But they are mainly related to, I would say, also with taxes and subsidies that might exist. So if they're already part of one of the regions we've analyzed within the project, then those would be already part of the platform, which means basically once the users are running their end the analysis at the end, or some of it at the beginning, if it's a requirement for the project, they will be able also to analyze it within this specific regulatory framework, so that if there are any subsidies, those would be included in the techno-economic analysis and in financial analysis, and if there are any taxes, those would also be reflected in the techno-economic and financial analysis. The tool is flexible enough though, so that the users, even if they're working from a different region, they can add let's say the specific taxes or subsidies that might exist for a particular region. Or for example, since this has to do also with it, we will be able to analyze on a systemic basis, for example, how much CO2 you might save by using this excess thermal energy to heat buildings, for example. That might be also used in the overall analysis of some policy instruments related, for example, with renewable directives or with energy efficiency directives, where basically you are increasing or basically incentivizing or increasing the energy efficiency of the whole system. So it's mainly just to give maybe just summarize it. So it's mainly from the taxes and subsidies aside for the time being.
Okay, thank you, Zenaida. So with that question and very detailed feedback provided from you, we have 10 questions. Pretty nice engagement of the attendees. So let me just briefly say some more words about Allianz in the last 7-8 minutes which we have. So we are open for other projects to join us, to join the Alliance. So the first one, it should be a EU-funded project and non-profit organization or association organization based in Europe, and work towards the decarbonization of the industrial sectors, as is given the example through the recovery and the use of excess thermal energy or integration of renewable in industrial processes. Those requirements are provided also in the bullet points on the website of the Alliance, which I'm going to show here, which is Alliance for EUSEW.eu. So our further activities are the common participation in EUSEW World Sustainable Energy Days at the beginning of March, which will be organized particularly by Zenaida, one of the speakers of today workshop, and you will be invited to it. Moreover, we are performing quite many other cross activities related with communication and dissemination of Alliance or particular projects which are the member of our alliance. Yes, we are dealing with this kind of the installation which we could see on this spot. So once again, I would like to say thank you for the EUSEW 2021 extended program to be involved in the event to provide the workshop of the Alliance under EUSEW identity. And from my side, I would like to thank you all the speakers from the Alliance members, for Andrea, Nick, Zenaida, and Max. And on behalf of Alliance, I would like to thank you all the attendees for the workshop. Your pretty nice engagement. It means that you are aware about energy intensive industry and about the challenges which are faced at this moment in the Europe, and you would like to be more involved. So thank you once again. Here you could find the contact for all the Alliance members, info@alliance4acei.eu. We are also present on the social media like LinkedIn and the Twitter, which you could find. And if you enter to the website of the Alliance, you will find more detailed information about our activities and also links to the social media. Thank you very much for your attention, and I hope that you will be engaged more in our dissemination communication events. Thank you.